Um, this should be a summary of what we've done so far on working towards infinite rectangles. All right, so if I were to give a right rectangle approximation method for the area under f equals 2 plus x squared on 1 to 5 using a sum of many sigma expressions, then let's start with the sum. I'm not going to even draw it. I feel like we're past that, but if you're very visual and it helps you, then please do so. So, when I sum, what am I summing? Sum of many? I don't know, man. I just push these symbols around. I don't even know it. What are you summing?
Area.
Area of what? Rectangles. Okay, perfect. All right, so you're summing many rectangles. If you want to start with the sum of many base times heights, fine. But if you want to bypass that and start going to the details, the nitty-gritty, so be it. The base. How do you think of the base? What's the base number? Delta x. Okay, it's how wide we're going. So what goes into that delta x calculation? Number of rectangles on the bottom and on the top? The interval. Okay, so in this case, the total interval is 4 wide, and we're dividing it into some number of chunks. So each base is 4 over n. That is delta x. It's the base of each rectangle. Right? The heights come from f at different points. Now, what point you draw the height at goes to a couple things. What are some considerations into where you draw the height? The end point, yeah, the starting point, the left edge. We're starting in this case at 1, and then how far you go over each rectangle is how many delta x's you go over. So in this case, it should be something like each delta x is a 4 over n, some number of times, which we call I, all right? Now because it's right rectangles, we're starting by going over 1 delta x to our first height, and ending at the last rectangle, which n stands for the number of rectangles. So far, so good? Yeah. All right. Then we started to go function specific. In this case, rather than f, the function is 2 plus whatever you put in squared. By definition in this problem. Now that's problem to problem. It changes. The function could be different every time. It could be different every time. What are we putting into the function? 1 plus. Okay. So we write the function specific, but with that same x expression going in. You with me? All right. The part that I did not communicate well yesterday, and I apologize for that, is how to break it well into pieces. So let's go over that. All right. The 4 over n, first and foremost, it's like a constant. The minute you said n is this, it behaves like a constant. So because it's a constant, it can be moved out front. It is not part of the counter. I is. Now I'm going to go pretty slow in my algebra. You, especially with practice, can consolidate these algebra steps into less, and that's fine. I just don't want to lose you. So I'm going to pull the 4 over n out front, and I'm going to prepare to expand this. The goal being to eventually just totally blow this up into lots of little segments, right? And why you want to do that, we'll talk about that tomorrow. You with me on that stuff? All right. If I then break this up, I would get something like 2 plus, what is this binomial expansion? 1 plus 4 over ni plus 4 over ni, which is 8 over ni plus 16 over n squared I squared. All right. So the last step then is to break this into lots of little pieces. Now that 4 over n is going to be out front of every little piece. How many summations could I write this in? I don't think I really need to write 4. I could make it 3 because that's 2 and 1. You agree? Okay, so I'm going to call this 4 over n times the sum of the constants summing to 3 from 1 to 3. Then a 4 over n times the sum of the times the sum of the 8 over n i's. Now, I told you that the n terms can be brought out front. So not only am I going to have the 4 over n out there, but I'm also going to bring that 8 over n out there. And if you wanted to leave it like that, fine. If you called it 32 over n squared, obviously that's fine. But that would be times the sum of i's, yeah? Correct me or if I'm making a mistake or if you don't understand what I'm doing. And then what's the last term? Out front is 4 over n and 16 over n squared, and what's in? I squared. That's the main objective for today. Tomorrow we'll take that just a little bit further. Boom, home free, okay? Home free being perfect area by taking infinitely many rectangles tomorrow. For now, that's what I want you to do, is to get to this step, a blown up summation. So, would you try that one? My goal is not only to get you to do this well, but also to get you to do it quickly. So let's do it in 5 minutes or less. Do feel free to consolidate steps if you feel comfortable doing so. I forgot to actually point to the time. How are we doing? So you could certainly skip a step or two from what I have. But when you get done, look over what we have and see if we agree, and if not, then let's talk about differences. You don't necessarily have to have simplified. For example, if you have 3 over n times 12 over n out here, that's fine. Or 3 over n times 9 over n squared, that's fine. As long as it's equivalent. How are we doing? Good? Okay. Give you a minute or go on to the next one. Okay, why don't you go on to the next two, and I will walk around, hand back some papers, and the idea is trying to not only get the concept, but make it a little more automatic, a little less, constantly thinking, how do I do it? How do I do this? Flow. What I have or something equivalent. Okay, how'd the third one go? Dish? Working on it. Okay. The last one's the worst. You might need a little refresher on binomial expansion. I don't know if you remember your expansion of cubes. Do you? A plus b cubed is that's the extension of c. This is the worst case scenario, is a cube of something that starts off of 0. Hey, how we doing, people? All right, so I'm feeling the last one might be something like 2 over n times the sum of a bunch of 1s. 12 over n squared times the sum of a bunch of i's. Maybe 24 over n cubed times the sum of a bunch of I squareds. And 16 over n to the 4th times the sum of a bunch of I cubes. The products up front, usually not. It'll maybe make the limit part of it a little easier, but it's not. Okay. All right. So if that's going well, then you are set up to. You're set up to succeed on one of the hardest problems of Calc 1, and that is infinite rectangles or a Riemann rectangles tomorrow. It'll go well tomorrow. If you're not with me, then come in the 7th hour so we can maybe figure out where you're having errors, but otherwise you'll be great tomorrow. Unfortunately, that's not the lesson. Today, we're doing the quotient rule. So, the quotient rule, would you get out that green note sheet, please? Quotient rule. In my craziness, I've already now taught most of set 43, but what you haven't learned is set 42. So, set 42, here we go. This is the last real derivative technique rule you have. You've got your product rule, you've got your quotient rule, you've got your chain rule, implicit differentiation, all these skills. You've got a lot of derivative skills. The only one you're really missing is the quotient rule. Now, you can actually get the quotient rule on your own, because any quotient could be written as a product. You could write a quotient f of x over g of x as f of x times g of x to the negative 1. Now this is one of the few times where math notation is just disastrous, because that notation typically means inverse when applied to a function. I'm using it in the sense of more like a numerical exponent, so think of that as to the negative first power, not inverse, which you do not know how to take the derivative of, all right? So my question then is this. I want you to figure out a rule. Given some quotient function, what is a rule for the derivative of that quotient using maybe this idea? Go. In other words, I'm not teaching you the quotient rule. You're going to come up with it yourself. Go. Work with your mathematics. Product rule, you can make a chain rule, you're good to go. First times driven second, second times driven first, product rule. Okay.
Okay, Jasper, so is this, how do you take a derivative? Derivative second? No. No, you move it out.
Oh, wait, we should have done this. Wait. So, wait. Okay, so it's probably fine. And then,
Now, yeah, it's actually.
so derivative. Okay, so f x is going to stay the same. And then g negative 1 comes down. So what's the negative? So negative 1 of x to negative 1 of x. What's the derivative of negative 1? Negative x. Okay.
Now, if I look at a little algebraically, that's not typically how we write it. Try and, now, once you got the product rule, then try and do some algebra to make it more like one big quotient. It's kind of logical that the derivative of a quotient is a quotient.
I think this is right.
So,
Times derivative of g double. Wait, what about the b? Negative b? No. Okay, now I'm asking you what oh wait. Which one stays the same? But it's not. 72 minus
so lots of cleanup to be done here before it's a clean, usable rule. Yours might look a little different. I took first times derivative second, and then second times derivative first, obviously because it's addition, if you switch those, that's fine, no big deal. This, be careful when you took the derivative of the g term that you did it well. It required the chain rule. The derivative of g of x to the negative second is negative 1 comes down, g to the negative second, the times term the inside, g prime. So check that chain rule part on g. You with me? Right, now that is the derivative. It's kind of cumbersome, I think you'll agree. So let's clean it up. If I were to clean this up, then I might have something like f of x, g prime of x, over g squared, and all of that negative for the first. And then maybe f prime over g of x just to the first. You agree with my algebra there? I just basically put the g's back in the denominator like they were to begin with. You cool so far? Yes? Alrighty then. If we get a common denominator, what is the common denominator? G of x squared. The denominator g squared. Alright, now I think you'll agree that this one is pretty good the way it is. It already had the common denominator. But this, what did you have to multiply it by to get the common denominator? You had only one g of x, you needed two, so you had to multiply it by another g. Do you agree? Okay, so I'm going to write that as g f prime. Last but not least, would you tweak the order so it's written this way? And so it rhymes. G of x, f prime of x. I'm going to write the positive term first. Minus f of x, g prime of x, over this g of x squared. Are you tracking? Now that is the quotient rule, and it's doggone hard to memorize. Thankfully, there's a mnemonic, which I say a little differently than Miss Kenna does. Okay? It goes a little something like this. Low. And when I say low, that means the function that was in the lower part of the original problem. D high. By d high, I mean the derivative of the upper function in the original problem. Low d high minus high d low over the square of what's below. Low d high minus high d low over the square of what's below. Low d high minus high d low over the square of what's below. Okay, are you tracking? The more you say it, the more you'll remember it. So h prime is low, which is g of x. D high is f prime minus high d low over the square of what's below is g all squared. All right. Now then, with the quotient rule, you can do derivatives of quotients, obviously. So, for example, if I wanted the derivative of f in that first example, I'm going to draw a big old fraction, and I start with low. Low is x squared minus 1 in parentheses. D high is the derivative of the upper function, which is the same. Yes, true. 3 to the x minus high. High is the same. D low, the derivative of the lower function is 2x over the square of what's below is the quantity x squared minus 1 quantity squared. That's the quotient rule. Leave it like that. You get it? Okay. Try, well, actually, I don't know if you know how to do that last one. Oh, you do. Never mind. It's the second derivative you don't know. All right, you should be good. Try those, please. As always, make sure you're labeling your work. It shouldn't just be a floating expression. Have F prime equals next to it. Never just float your answer. Always want labels. Second one required a little more skill. You had to use a chain rule. How'd it go? Yeah. Okay. Don't forget the stick. Okay, so the last one, besides the quotient rule element, there's some pretty hairy algebra in there, yeah?
It's not.
Because the, did I make a mistake?
You don't have it.
You don't have that? That's the hardest one. I must have felt like it was disastrous last year. I think I killed your spirit. I'll kill your spirit. Yes. Oh, sorry. I think I was jumping ahead of myself and already combining the chain rule. This should have been -2. And then a 2 later. Sorry, you're right. Thank you. My bad. Okay. So you don't have that problem. I'm just doing this for fun. Never mind on this. Do you have the second derivative implicitly on yours at the bottom? Yes, you do. Yep, gotta do it. Okay, here we go. That's not what you have. Do you have something about the second derivative at the bottom of yours? Yes? Implicitly. Hang on 1 minute. This is important. This is an improvement over last year. Hopefully it'll cause us to be successful earlier. Okay. I don't know if you people from Miss Cannons did this last year or not. It kind of depends on whether she put it in early or not. All right. So you'll often see the quotient rule when taking the second derivative. The first one, this should go pretty well. The second one is where you'll need some help. So would you do part A for me, please? And then we'll talk about part B. Part A is review. It should be no problem. something like that for my derivative. How about you?
Yeah.
I agree.
Okay. All right then. Now, when you take an implicit derivative, it's very common that you have a quotient. It often involves dividing the dy dx components over. So it's pretty expected to get a quotient over here anytime you do an implicit. Not every time, but most times, all right? Now, if you then found the second derivative of an implicit, then you're going to have to take the derivative of the derivative. So if you want the second derivative, then I need to start with what I had and take the derivative with respect to x of both sides. When I do that, the left side is the derivative of dy dx, which is the second derivative of y with respect to x. The writing of it, the notation of it is something you'll gradually start to make sense of. But for now, let's talk the right side. Here we go. We have a quotient on the right side, yes? Low is 3y squared minus 4. D high, what's the derivative of negative 2x? Hello, I feel like a low. Negative 2, yes? Minus high. Negative 2x. Here's the gotcha part. D low. 6y dy dx. Over the square of what's below. Now this then, we have one more step. We're supposed to find the derivative, but in terms of x's and y's. So what's the problem? What do we need to dump? The dy dx. We need to now sub for that. Sub for dyx at the end, dy dx at the end. So we're going to have 3y squared minus 4 times negative 2. I'm going to go with plus 2x if you don't mind. Times 6y, but in place of dy dx, I substitute in what? That, yeah, that. Negative 2x over 3y squared minus 4 all over 3y squared minus 4 quantity squared. Now this second implicit derivative actually doesn't come until later in the book. So by putting it in a little early, it allows me to put some AP practice on that I'd like to get you all year long instead of just the last 3 months. So that's why I'm teaching it a little ahead. That and because I think you're so darn smart. Are you with me? Ish. Ish. I'll take ish. Okay. Would you then? So the whole backside is combining quotient rules with big ideas of the calculus. So first derivative test to find extrema. Finding where something is increasing. Finding where there's a horizontal tangent. Graphs and tables. So I'll give you 10 minutes to work on this. Actually, do you have a homework to turn in? The fun, oh yeah, but we pretty much did. The front sheet's good, right?
We didn't get examples for the last.
I did. We did it. We're good. Okay, so let's do is the preset 43 fun sheet, yeah? And it's mostly done.
Yes.
Thank you. What would I do without you two? Because you go a bunch of stiffs up there. Okay, it's pretty much just us. You speak once in a while. You guys are working. You don't speak at all. All right. You guys could be smoking back there. I wouldn't. Please don't. That's it. Same as you. If you speak smoking back there. All right. My point though is this: if you're from the standards class and you feel like you could just feel the backside applications of the quotient rule, fine. But if you're not, if you're new to the class, it's hard to strongly recommend you do the backside of this notice. Don't just there. Okay, so I'm just gonna walk around for the last 20 minutes, help you, 15 minutes, 10 minutes, and help you.
Wait, so do we submit it?
Yes, turn in front sheet. I will help you read through this and I'll help you on the notes.
You're the kind of person that signs up. You were the kind of person who pulled that in. You were almost crying. You just heard your voice. You were about to just like, right. You were about to get that. Combined.
Didn't exist. The derivative is not going to be a thing. Those aren't gone. So I'm not going to change it. So from here, you're going to say, where is the the lesson? Yeah. Just kind of talk about it. That's correct. Yeah, no problem. I'll give you the same thing I did. For them, let me get a pencil, I'll be right there.
Haley, not this one. What is that? That's the ad. No. Okay. Yeah. It's like, is it preset? I think 42 is we already have 42 for today. Yeah, we have to turn tomorrow. We didn't go over any of this stuff. Yeah, it says 40. Okay. 41. Oh, I got it. This is due tomorrow.
You just let me do it over here. Did you get moving to the voice?
I think I did. I'm almost positive.
But they can't be positive. Why can you not do this?
Oh, I just like
Why are you sitting equals 0? What's he doing?
Oh, I did that.
Multiple things to negative 2 and that's negative 1. That just applies to negative 2 and that's negative 1. You trust the process. You trust the process. What adds to negative 2? Or what multiplies to negative 2 and adds to negative 1? Jasper, you trust the process.
So, but this one's right, right?
Yeah, there's no one. Yeah, you're right. Red and green. Curious, how do you green limit there? Yeah. Tell.
Am I doing this right?
It's just, it's set to your own, and then you like, suddenly it's like,
Hi, Harvard, how are you? Can I come on the left? Actually, how do you teach this thing? I'll do it on class.
I'll see the words. Two. That's 16. Alright, you want me to teach you California method?
I do. Will you please turn in that addendum? That's a 5-point assignment. I often do get class assignments for 5 points, so that'll be a 5-point. Please turn it in.
But it's like 50 pages.
PT 16 and a half through
Girls Center. We have several girls who have not completed TDMS. We will be needing teachers for a 10A bring 5 velvet and shirt size.
oh yeah.
Staff and administration covered. Help support the volleyball team by donating seed cake from any volleyball player. As staff has ordered, or at staff has ordered to be cake by next Tuesday. Don't miss out on these delicious flavors such as New York style, key lime, and circle, and 22 for cheesecake. Summer at University from Malibu, California will be here tomorrow at 1:45 p.m. This is during 6th hour as the schedule will be different during UT at 16 next week. Leah Pass from Southside Governor.
I watched this thing out of it.
Seniors, take note. Governor Hickenlooper has announced a free college application day for every public college and university in Colorado. You can apply for free on Tuesday, October 30th. Each institution will waive fees differently. Be prepared to read the instructions and have your high-quality application ready before October 30th. This will save you at least $50 per application. single mile. Noah has been a big part of our team, team 5 to 1 start to the 2018 season. Noah currently ranks second on the team in total tackles and first in tackles for loss. Noah leads the state in punt average, touchdown inside the 20-yard line of goal. Noah has an incredible work ethic and really has become an exceptional leader for us on and off the field. That's all your announcements. Have a great day.
I wish I would have made you do that critical number one. It was hard.
You did it in that game.
No, I'm not.
Yeah, it is. So is it no or is it so?
You should be tuning two things in. The addendum and the 43 fund sheet, both white, I believe. The addendum and the 43 fund sheet are both due. Yes.
Another set 43 fun sheet. I see your lost one. Thank you.